Alright, this video is for Unit 5, Lesson 3. Today we're going to be focusing on factoring, but a little different than we have in the past. Last time we talked about the remainder theorem and we could test one root or one factor, but now today we're going to find all of the roots by factoring, or a complete factorization of the polynomial. Next time is a lot like this time, but next time, instead of focusing on real roots, we're going to be focusing on complex roots or irrational roots. So we're going to be using a lot of what we learned about last time today. A quick review, the fundamental theorem of algebra tells us that if the degree of a polynomial is n, that means it has exactly n roots in the complex numbers. So what that means is that that power of the polynomial, it tells us how many roots it should have. So in this first polynomial f of x, the leading coefficient is, of course, 4. You should all be experts at this. And the degree you can see is 3. So that means this polynomial has to have 3 complex roots. This next polynomial, g of x, has a leading coefficient of 1, and it's a degree 4 polynomial, so it has 4 roots. J of x has a leading coefficient of 1/2, and that's just a power 1 function, so it only has 1 root. K of x is in intercept form, but if you think about each of those factors, you could decide that it has a leading coefficient of 1 if you multiplied it all out in standard form, and the degree would be 3. So it has 3 roots, and we can actually immediately tell what those roots are. P of x is also in intercept form. This one's a little bit hard to figure out what the leading coefficient is, but it has a 3x in one of its factors, and it has a 1/3, so it actually also has a leading coefficient of 1. And the degree of this would be, we have 1, 2, 3 factors, but this one has, this x minus 1 has a multiplicity of 2, so that means it's degree 4. So again, I got degree 4 because I thought about that there's 2 factors of x minus 1, plus this one, that's 3, plus this one, that's 4, degree 4. Okay, and so we know it has 4 roots. Well, if I was listing the roots out, I'd be like, it's 1, it's 5/3, and it's -4. So sometimes it seems like there's only 3 roots in this case, but this one has a multiplicity of 2. So it does have 4 roots. It's just 2 of the roots are the same. Okay, so remember that when one of those factors has a power, when one of the roots has multiplicity, it just means that one of the roots is repeated, or one of the factors is repeated, like it's shown on the board here. X plus 1 squared is the same as having that factor twice. So this equation still has 3 roots. It is degree 3. It's just that the root -1 has a multiplicity of 2. Okay, so let's get into our new stuff for today. I just wanted to review that. So today we are going to be factoring trinomials, sorry, not trinomials, cubic equations, and it's going to be a little different than we have factored in the past. Before, if we tried to factor this cubic function, we would maybe notice that it has 4 terms, and we would perhaps try grouping, but in this case, grouping doesn't work. Grouping fails. So we need another strategy to try. So if we notice that it has a -21 here, we might be able to think of possible factors that might work. For example, maybe it has a factor of x minus 7, or maybe it has a factor of x plus 7. 7 is one of the factors of 21. Or maybe it has a factor of x minus 3, or maybe it's an x plus 3, or it could be an x plus 1, or it could be an x minus 1. And you can kind of think of what the possible factors of the equation might be. And what we learned last time is that we can test these factors, and when we test them, what we're looking for, what we're hoping to find, is some factor that gives us a remainder of 0. If we can find a remainder of 0, then we know we have found one of the factors. So last time we learned that we could substitute values into the function and evaluate the function. Today we're going to look for those remainders of zeros just like before, but we're going to actually look for those remainders in our synthetic division. So here's our polynomial's coefficients. If I wanted to test this first factor, x minus 7, I would use the 0 or the root 7. And if we divide that 1, multiply it, put it in the next column, multiply it, 112, add that up, 123, multiply it. Oh my goodness, this is a big number. I need my calculator. 123 times 7 is 861. And if we add that column up, we get 840. And that tells me, this remainder tells me that I did not find a factor. X minus 7 did not work. Well, x minus 7 didn't work. Let's test x plus 7. Okay, well, if we want to test x plus 7, we would use the root negative 7. Here we go. Let's test it out. We're looking to find a remainder of 0. Drop it down, multiply it, add it up, multiply it, add it up, multiply it. Hey, look at that. We found our remainder of 0. Yay! So that means x plus 7 is one of the factors. Now, we could keep testing factors until we find the other ones. This is a degree 3 equation, so we should, if it's factorable, be able to find 3 factors. But at this point, now that I have found one of the factors, I wouldn't keep testing them. I would think about this result right here. When we divided, we were left with x squared plus 2x minus 3. That result is going to give us our other 2 factors. What we've done so far is we broke our function into x plus 7 and x squared plus 2x minus 3. We're really close to having it factored completely. We just need to think of how to factor this trinomial here, and let's see, we're thinking about that negative 3. It looks to me like it's going to be this, x plus 3 and x minus 1, and that is factored. So we tested until we found one that was a factor. We used the result of the division to find the other 2 factors. Here's what the graph looks like. We happen to find this factor first, and that happens to be here on the graph. And we found these other 2 factors, and hey, look, there they are on the graph too. I like to show you the graph. because it's fun to see the graph. Okay, here's another one. Well, our polynomial this time has a -6 at the end, so we need to try to think of one to test. You know, we've got a lot of possibilities here. It might be an x plus 6 or an x minus 6. It could be an x plus 1 or an x minus 1, or it really could be an x plus 2 or x minus 2, and it could be this. These are the possibilities. We know we have a -6 here at the end, so one of these is bound to work. Well, you just pick one to try. Maybe we'll try this one. Let's test this. So if we set up our synthetic division, and we drop it down, multiply it, add it up, multiply it, add it up, multiply it. Should be able to do that in my head, but it's been a long day. 114, add it up, -120. That means we failed. That is not a factor. X plus 6 is not a factor. Well, let's try another one, and maybe we could try x minus 6, or maybe we'll pick a different one. Let's pick this one. If we want to test x plus 1, we would use -1. Drop it down, multiply it, add it up, multiply it, add it up, multiply it, add it up. Hey, look at that. That was pretty lucky. I was just picking one to test. So we divided it and we got this result. So that means so far we have an x plus 1 and we have this quadratic right here. So if we want to factor the polynomial, we can just think of a way to factor this quadratic. Well, we're thinking about the factors of 6 here, and I think we're trying to get a positive 1, so we need this combination. Okay, so we have factored the polynomial. Again, that process was we just chose some factors to test until we found a remainder of 0. That told us we found one factor. We used the result of the division to find the other 2 factors. And here's the graph of it. The scale is kind of funny. It's by 2s, but here's the -3 intercept, here's the -1 intercept, and here's where it goes through the value 2. So that factorization matches that graph perfectly. Okay, I had an activity you could do in class, but you weren't in class. Okay, so oftentimes we don't have to just guess. Oftentimes I will just give you one of the factors and I will ask you to use that information to find the other factors. So here's our polynomial: 3x to the third minus 16x squared minus 103x plus 36. This would be very difficult to factor on our own, but if we know that one of the factors is x plus 4, it's not too hard to find the other factors. So we're going to use synthetic division to help us. And since we're dividing by x plus 4, we will use the 0, -4. So we drop it down, we multiply it, and we add it up. And we multiply it. -28 times -4. 112, and we add that column up, and we get 9, and we multiply and put it in the next column, and we add that column up. So we got a 0 remainder, which we should have been expecting because we knew it was a factor, so we were expecting a 0 remainder there. So what we have is 3x squared minus 28x plus 9. Our other 2 factors are going to come from this polynomial. that we need to now factor. Well, it looks like we're going to have a 3x and a 3x. And on the other end, we might have 9 and 1. We might have 3 and 3. We got to kind of play with it until we find the right combination. I feel like 3 and 3 is not going to work. Nope, that would give us a 12 or a 6. And you're all getting to be experts at factoring, so you can, of course, try to factor this yourself. Let's try the 9 and the 1. I'm trying to build a 28, so I think the 9 can go there, the 1 can go there. That gives me a 1x. This gives me 27x. We can definitely make that into 28x if they are both negative. So we found our other factors. They are 3x minus 1 and x minus 9. So the polynomial in complete factored form would look like this. So here's the graph, kind of fun to look at. The other two factors were 3x minus 1 and x minus 9. And you can see the original factor we knew was x plus 4. So that meant it should have had an intercept at negative 4. We found the factor x minus 9, and you can see the graph has an intercept at 9. 3x minus 1 goes with the 0, 1/3, and you can see that one on the graph here between the 0 and the 1. Okay, this one was for you to try. I'll go ahead and do it now. We know one of the factors is x plus 6, so we're going to use the 0, negative 6. We drop it down, we multiply it, we add it up, we multiply it, we add it up, we multiply it. We got 0, just like we were expecting, because we knew x plus 6 was one of the factors. So we have the result down here, x squared minus 4x plus 4. Our other two factors are going to come from this polynomial. So if we factor it, it looks like we're going to have x minus 2 and x minus 2. Interesting. So the complete factorization of our polynomial would be x plus 6 and x minus 2 squared. Let's look at the graph. Hey, look at that. It goes through at negative 6. That was the factor x plus 6 that was given to us. We found two factors of x minus 2, which means it has a root of 2 with multiplicity. And look at that graph behavior. It comes down, touches the x-axis at the value 2, and then turns around and continues up. Okay, fun times. Okay, so just want to remind you about the relationship between the factors and the zeros and the x-intercepts. If we have a factor of x plus 5, you know that the 0 is negative 5. And on the graph, that x-intercept would show up at negative 5. Well, if it has a 0 at 5, that shows up on the graph at the point 50. The factor that is associated with that is x minus 5. If the x-intercept is at negative 3, 0, that means negative 3 is a root of the function, and a factor of the function would be x plus 3. If it has a factor of x minus 3, you know the 0 or the root that goes with that is positive 3, and we would see that as an intercept on the graph. If it has a 0 of 8, we'll see it on the graph at 8, 0. And if it goes through that intercept and has that root, we will see a factor of x minus 8. So as we do these next few problems, we need to keep track of or remember this relationship so that we aren't just randomly changing signs. Okay, this one says 8 is one of the zeros of the function. What are the other zeros? Okay, well, if 8 is one of the zeros of the function, we can use that fact to divide. Now, I don't need to change the sign because 8 is the 0. When we are doing synthetic division, we use the 0. Now, that happens to mean that x minus 8 is a factor of the function, but we use the 0, 8 to divide. So let's go ahead and divide this. We drop it down, we multiply it. Oh my goodness, 15 times 8. 120, and we add that up, and we multiply it, and we add it up, and we multiply it, and we add it up. And thank goodness we got 0. We should have been expecting that because it says 8 is a 0 of the function. So now we have this polynomial, 15x squared plus 1x minus 2. We want the other two zeros of the function, so we're just solving this equation. What are the other two zeros? And we get to factor this to find those other two zeros. 15x squared, let's see, I'm thinking it will maybe be 5x and 3x. If that's not working, we'll have to switch to 15 and 1. And we need a 2, negative 2. So let's see, we could put a 2 here and a 1 here. That gives us, here's a 6x, and here is a 5x. We're trying to add it up to 1, so we want the 6 to be positive and the 5 to be negative. Okay, so our two factors are 5x plus 2 and 3x minus 1. So the other zeros of the function are negative 2/5, so we subtract the 2 and divide by 5, and the other one is positive 1/3. Let's look at the graph. Here it is. Now it's hard to see, maybe. This is the 0 that we were given, the 0, 8. The other one is 1/3. You can see it here between the 0 and 1. And the other one was negative 2/5, about negative 0.4 right here. So you can see all three of those zeros on the graph. Okay, here's one for you to try if you want to do it along with me. That's fine. If you want to pause and try it yourself, that's fine. We are given negative 7 as a 0 of the function. We can use that 0 to divide. Remember that it has a 0 at negative 7 means x plus 7 is the factor. Okay, so we drop it down, we multiply, we add it up, we multiply, we add it up, we multiply, we add it up. I have an error. I can add. Here we go. Negative 45 plus 70, that should have been a 25. 25 times negative 7 is negative 175. Sorry about that. Okay, so we've got this result to our synthetic division. That tells us that we have this polynomial. And our question is, what are the other zeros? Well, the other zeros come from this quadratic. So we have to think about how to factor this. And that will give us our other zeros. We've got an x and an x. And it looks like we need a couple of 5s, and they're both negative. So it looks like the only other distinct 0 is 5, but it has a multiplicity of 2. So we still have our 3 roots accounted for. It's just that 2 of them are the same. Let's see the graph. So if we look at the graph, here's the negative 7 that we were given, and here is the positive 5, but it has a multiplicity of 2, so it causes this this behavior, this tangent behavior at the x-axis. All right, well, that's it. So it's not, I hope, not too intense if you've been in class on our other lessons. If you have questions, we're getting towards the end of our unit. Please come in and get them resolved before the test. Thank you.